In this example, I need to solve the inequality and write the answer in interval notation. Here's the inequality. It's x cubed plus 3x squared minus 9x minus 27 is greater than or equal to 0. Well, what type of inequality is this? Notice the highest exponent on an x is a 3, so this is a polynomial inequality. And here are the steps for solving polynomial inequalities using the boundary point or critical point method. Step 1 says find the boundary points by changing the inequality to an equal sign and solving the resulting equation. The real solutions of this equation are the boundary points. So going back to our inequality, I'm going to change this greater than or equal to into an equal sign. So I'm going to have x cubed plus 3x squared minus 9x minus 27 equals 0. And now I need to solve this polynomial equation. How many terms are there in this equation? There's 1, 2, 3, 4 terms, so let's see if it will factor by grouping. So looking at the first 2 terms, what do they have in common? An x squared. If you factor an x squared out of an x cubed, it's going to leave x plus, and factor x squared out of 3x squared, it's going to leave a 3. Then bring down the middle sign, so I'm going to factor out a negative. What do the last 2 terms have in common? I think they have a 9, so I'm going to factor out negative 9. And when you factor negative 9 out of negative 9x, it's going to leave x. Factor a negative 9 out of a negative 27, it's going to leave plus 3 equals 0. Did factoring by grouping work? Is this binomial the same as this one? Yes. So x plus 3 is your common binomial factor. You factor it in front, and what does it leave behind? X squared minus 9. So now leave the x plus 3 alone. Does x squared minus 9 factor? Yes, it's 2 terms. It's the difference of 2 squares. And that's going to factor into 2 binomials. What is the square root of x squared? X. What is the square root of 9? 3. And you need opposite signs in the parentheses. One has to be positive, one has to be negative. Now I can simplify this a little bit because I have x plus 3 times x plus 3. So I'm going to write that as x plus 3 all squared times x minus 3 equals 0. So now I've factored my polynomial, set each factor equal to 0. So I know x plus 3 all squared equals 0, or x minus 3 equals 0. If x plus 3 all squared equals 0, you know x plus 3 is 0. Subtracting 3 from both sides, you get x equals negative 3. On the second one, x minus 3 equals 0. Add 3 to both sides, you get x equals 3. Now these 2 values, these are the boundary points for this problem. So looking at our steps, I've completed step 1. Step 2 says to place the boundary points on a number line in the correct numerical order. This divides the number line into intervals. So I need a number line. So here's my number line. And my 2 boundary points, negative 3 is less than 3, so I need negative 3 on the left. So here is x equals negative 3. And here is x equals positive 3. They divide the number line into regions. So I have the region to the left of negative 3, the region between -3 and 3, and the region to the right of 3. So that is step 2 completed. Step 3 says choose one number called a test value from each interval and determine if the inequality is true or false at that value. Select the intervals where the inequality is true. So I'm going to need test values in each region. In the region to the left of -3, I'm going to pick x equals -4. In the region between -3 and 3, I'm going to pick my lazy arithmetic point, x equals 0. And to the right of 3, I'm going to pick x equals +4. To save time, I'm going to put the video on pause for a second. So I plug my test value of x equals -4 into the original inequality. So here, here, and here. And that gave me this statement. -4 cubed is -64. -4 squared is 16. 16 times 3 is 48. -9 times -4 is +36. Minus 27, is that greater than or equal to 0? When you add up all of these numbers, you land up with -7. Is -7 greater than or equal to 0? That is a false statement, so I do not want the region to the left of x equals -3. Looking at the next test value of x equals 0, plug 0 here, here, and here, I get this statement. So the first 3 terms turn into 0, so I just get is -27 greater than or equal to 0? Again, that is a false statement, so I do not want the region in between -3 and 3. Finally, looking at the test value of x equals 4 in the last region, plugging 4 into the inequality, I get this statement. 4 cubed is 64. Then I have 4 squared is 16 times 3 is +48. -9 times 4 is -36. Minus 27, is that greater than or equal to 0? Adding all these numbers up, I get 49. Is 49 greater than or equal to 0? That is a true statement. So I want the region to the right of x equals 3. So going back to our steps, I have now completed step 3, and step 4 says the boundary points are included in the solution set if the inequality is greater than or equal to or less than or equal to, and I need to use square brackets. The boundary points are excluded from the solution set if the inequality is greater than or less than, and to use parentheses. So looking at our problem, I have greater than or equal to. So my boundary points have to be included. So that means I need to use a square bracket on this interval. So definitely this is part of my solution set. But both boundary points have to be part of my solution set. So I also need to include x equals -3. So the last thing I need to do is write the answer in interval notation. I need to include the point -3. So you put it in braces. So I have the point -3 unioned with this interval here, which is square bracket 3, comma, all the way to infinity. So there is my solution in interval notation. One last thing I want to point out is if this inequality was just greater than, I would not include -3 as part of the solution, and I would have to have a parentheses on the +3.